Now what about the strength of these bonds? We've said before that the single bonds are weaker than double bonds. We've said double bonds are weaker than triple bonds. And that we get closer as we make extra bonds. We go from 154 length for the carbon-carbon single to 134 picometers for the double bond. And then even closer to the 121 picometer for the triple bond. But notice, while the triple bond is definitely stronger than the double, which is in turn stronger than the single, it's not that they're actually multiplying. We didn't go to 700 kilojoules per mole. And we didn't go to, 1050 kilojoules per mole for the triple bond. That's because the sigma bond, the first bond, has a better overlap than our pi bond. Now we'll revisit the strengths of our bonds and actually connect that back. So you can see here I'm pointing at table 9.2 out of the textbook, but I'm really going to focus on the carbon-carbon single bond, carbon-carbon double bond, and the carbon-carbon triple bond. Because what we're trying to highlight is just single, double, and triple bonds here as we go through the strengths of our bonds. Now we know that our triple bond should be significantly stronger than our double bond, and sure enough it is. And our double bond is stronger still than our single bond. True, but notice, if we were to double this value, if we just call it 350, we'd expect this to be at 700 kilojoules per mole. But it's not. It's still weaker than we'd expect if we doubled the bond. And if we were to take 350 and triple it, we'd expect to have 1050 for our bond. And this is not 1050. We're off by about 110. Actually 210 kilojoules per mole. So we can see that it's not going to just stack up. And we always need to make sure that if we're talking about a single bond, we look up a single bond. If we look for the energy of a double bond, we must look at the double bond. We can't decide what it is just by doubling this value. For the triple bond, we have to look that one up specifically as well. But why? Well, simply put, we said that the sigma bond has better overlap than our pi bond. And if you have better overlap, we expect you to be stronger because the electrons are being shared more. With a pi bond, remember, they're being shared, but that edge-to-edge overlap means oftentimes it wasn't being shared, which means it's not so strong of a bond. And you can see all those numbers just rephrased here so that it's a little easier to make out in your notes later on. So our single bond is worth about 350. If we were to double, have two single bonds, we'd expect it to be about 700 kilojoules per mole, but it's not that much. We're about 80 kilojoules per mole less strong than you'd expect if you did it the wrong way. That's because that 70 kilojoules per mole difference is from the weaker overlap between those pi orbitals. So we can see that that's not going to give us the same multiplicative effect. We actually want to make sure we always look them up whenever we're talking about energies.